Hi guys, this is going to be a video looking at inductors in that intermediate stage between 0 time constants and 5 time constants. As we saw, at 0 time, the voltage across the inductor is going to be the maximum it can possibly be, or E volts, the voltage of the power supply. As 5 time constants elapse, that voltage will drop down to 0 as if it were a short in the circuit. So in this example, if we have a power supply of 20 volts, a resistor of 2 ohms, and an inductor of 4 henries, the time constant will be L over R, or 4 henries over 2 ohms, which gives us 4 over 2 seconds. For this simple circuit, the time constant will be 2 seconds, resulting in a steady state after 2 times 5, or 10 seconds. But what if we want to figure out the voltage across the inductor at, let's say, 4 seconds? Or maybe the voltage across the inductor after 7 seconds? How would we figure that out? To find the intermediate voltage across an inductor between 0 time and 5 time constants, you use this equation here. You'll notice it's similar to the equation we used with capacitors to find the intermediate voltage, with one difference being that there's no 1 minus E in this case, and instead of having negative T over RC, we now have negative T times R over L as the exponent to E. So why don't we just plug some values in and see what voltage we get at 4 seconds. So voltage across the inductor at 4 seconds equals E, our voltage from the power supply of 20, times small e to the negative, and our time at this point is 4 seconds, times a resistor of 2 ohms over a 4 Henry inductor. Plugging that into a calculator, we get negative 8 over 4, which is negative 2. So e to the negative 2 times 20, and we get 2.7 volts. So after 4 seconds have elapsed, there exists a 2.7 voltage difference across the inductor. Solving for 7 seconds, voltage across the inductor at 7 equals 20 times e to the negative 7. Resistor is still 2. The measure of 4 henries for the inductor is still 4. So e to the negative 14 over 4, we'll just plug that into the calculator. Negative 14 divided by 4, e to the negative 3.5 times 20, we get 0.6 volts. So after 7 seconds have expired, the voltage across the inductor is now 0.6 volts. Here's a quick check to verify that this is the proper equation to use. Remember, with inductors, we're predicting that at 0 time there should be the full voltage across the inductor. In this case, we're expecting 20 volts to be across the inductor at 0 time, and after 5 time constants have expired, we're expecting there to be 0 volts across the inductor. While plugging in 0 and 10 into this equation, we get answers that are close enough to this prediction. The first case, at 0 time, we get exactly what we predicted of 20 volts, and after 10 seconds or 5 time constants, we get an answer that is fairly close to 0, our predicted voltage.